What's up? So in this video, we're going to estimate the Rotterdam demand system, and I have a lot of code here. Uh, and I'm not going to really go through every single point, but I'm going to go and talk about I go about estimating this thing using only expenditure data. Now, the data I'm using is going to be the same that we used for our linear expenditure system video, which is our Statistics Canada data, and the one thing that you have to note with this is that I have to go get information on prices. Now, the way I'm calculating, our estimate for prices is that I'm going and tasting the ratio of the gas expenditure all over the fitted values for this simple linear regression of gasoline on time. Now, this over here, this is just, a simple way to go and get, some estimate of prices. This isn't really, an official way. But the main idea for me going about doing this is so we're able to go and, get an estimate of, some sort of price variation. The idea would be that, there's that most growth in expenditure over time is driven by an increase in the demand by quantity, not by nominal factors like price. Now, this, could be, demonstrated, wrongly if you're in a country like Zimbabwe, but in a country where you have, pretty stable, monetary policy, this is the best guess that we have over here. So taking this ratio, and, I'm going to have to go take your differentiated, logged prices, as in the first difference between those two, and, get your estimates of your shares over here, or this moving average sort of shares. And it's important that you load this dplyr package, because that's the only way you'll be able to go and use this lag function properly and really get these estimates. And we have each these gas shared things. We're going to be actually taking away the first element, because that's just going to be an NA. So let's actually just, run the system, right? As you can see from my code, I've already ran it here. So this is the Rotterdam system in all its glory. And we are running it using Char. And, it's really, really, really cool in terms of, the actual significance over here. One of the cool things about this is that we can actually go and check, two of the main things, like Cournot aggregation, by looking at these coefficients from each one of these systems. So looking at, each set of equation, we can go and check, approximately, are we satisfying Cournot aggregation. So here, again, we see that, it's not perfect, right? But, it's pretty close to zero. I mean, some would say that, 0.05, right? That's, not close to zero. So, that would be, problematic. But that's, pretty close. I can at least say for the second one, which would be for the electricity regression, that's pretty close. For angle aggregation, that's almost bang on there. So, but one of the things that we should know is that for Slutsky, the Slutsky matrix symmetry, right? That's definitely not satisfied at all. We can go and we can see that if we were looking at the gas regression, right? The gas regressing, our gasoline expenditure on electricity price over here. Those cross elasticities, which is our interpretation of our coefficients, should be the same. So if we look at gas on electricity price, that's negative 6.162. And if we were to look at electricity on gas, where is it over here? So electricity on gas, yeah, that's going to be something positive. So that's, that's very, very, very strange. So I just want to go and show this as a way to go and say that, yes, you can pull this off, and you can go and check for theoretical restrictions. Let me know what you think. Did I do anything incorrect here? What do you think about this way to go and obtain an estimate for prices? It's just, a best guess. Let me know.